Thank you for visiting Natural Facts channel. Don't forget to subscribe, like and share. Be sure to hit the bell for future content on this channel.
They might seem like the strong, dull and silent type, but trees actually communicate with each other. Forest ecologist Dr. Suzanne Simard, from the University of British Columbia, studies a type of fungi that forms underground communication networks between trees in North American forests. Big old trees, dubbed mother trees, are hubs in this mycorrhizal fungal network, playing a key role in supporting other trees in the forest, especially their offspring. If you're a mother and you have children, you recognize your children and you treat them in certain ways. We're finding that trees will do the same thing. They'll adjust their competitive behavior to make room for their own kin, and they send those signals through mycorrhizal networks, says Simard. We found that the biggest oldest trees had more connections to other trees than smaller trees. It stands to reason because they have more root systems, she says. So when a seedling establishes on the forest floor, if it's near one of these mother trees, it just links into that network and accesses that huge resource network. Fungal networks don't just operate between related trees, but also between trees of different species in the same native community, says Simard. In a landmark experiment, published in a 1997 issue of Nature, Simard used radioisotopes to trace carbon, nitrogen and water moving between a Douglas fir and a paper birch tree, which are both native to the inland forests of British Columbia. When she shaded one tree, carbon-based sugars would flow into it from the other tree. So rather than competing for resources, these two trees were using fungal networks to share them, says Simard. In another study, Simard and her graduate student showed every tree in a 30 by 30 meter forest stand was connected to every other tree, with an estimated 250 to 300 trees being connected together in this single forest stand. Other evidence shows trees use fungal networks to warn their neighbors about impending attacks from pests. When trees are attacked, they increase their defense against the invaders by upregulating their defense genes to make defense enzymes, says Simard. Research suggests they also send chemical signals down into their roots through their mycorrhizal networks to their neighbors, which then detect these signals and upregulate their own defense genes. Lab studies have recorded defense signals traveling between trees in as little as 6 hours, says Simard. She says when fungal networks are intact, they allow a greater diversity of trees, each with their own strengths and weaknesses, to survive in the forest. This diversity is the basis for forests that are resilient to disease, pests and climate change, says Simard. Plant physiologist Professor Hansa Lambers of the University of Western Australia says scientists have known for 20 or 30 years that plants communicate by giving off chemicals above ground. The classic example is the release of volatile chemicals by plants that are attacked by pests. These chemicals are picked up by neighboring plants, which are then forewarned to defend themselves from the pests. The neighbors must sense those volatiles, and then respond by accumulating the chemicals that deter the attackers, says Lambers. Above-ground chemicals can also attract predators that eat pests, and more recently this chemical communication has also been found to occur below ground, says Lambers. But whether mycorrhizal fungi networks are used or not depends on the particular ecosystem. The Western Australian ecosystems, where Lambers works, are dominated by benches, grevilleas and hecas that don't rely on mycorrhizal fungi. However, eucalypt forests do have mycorrhizal fungal networks, says fungal ecologist Professor Ian Anderson of the University of Western Sydney, although no research has been done looking at their function. No one's actually shown that an interconnected network is transferring carbon and nitrogen, he says. It's a really under-researched area. Anderson suspects fungal networks would be playing an even more important role in eucalypt forests than North American forests, given their soils have much lower nutrients. I think these mycorrhizal networks have an even greater potential than what Suzanne Simard has shown, he says. There is so much more to learn about the networkings between trees. Stay tuned to Natural Facts channel.